Okay, let's actually set a timer this time. I think maybe I couldn't see it with my music blasting. I don't even know if I'm like um, comprehensible when I'm speaking over music. I'm probably talking way too loud. Okay, anyways. So I do like restructuring the code kind of like this. Obviously, this doesn't make as much sense anymore. Um, we could kind of like give some insight as to what the hell is going on there, though. R, G, B, and A. A little bit of padding. And what's wrong here? Oh, I see. Okay. Obviously getting more decorative than I really need to be. Okay. Red, green, blue, alpha, 0, 1, 2, 3, component index being the first index of that pixel, and we're multiplying by 4 up here. So that makes sense. Let's see how we're unpacking here. Red, green, blue, alpha in the correct order. Unsigned integer variable. 24, 16, 8, and 0. That sounds about correct. 0 definitely makes sense. 8 is because there's 8 bits per pixel, and we're shifted over to the next position, adding another 8 to get to the next pixel. 16, adding another 8 to get to the pixel after that. 24. So that all looks like it checks out pretty well. And we're going to clean up that indentation a little bit. And we're just going to keep on rolling on through here until we've kind of like gotten everything aligned to our strict column limit. Right? So I know it's kind of OCD to have this strict column limit, but think of it as a plus because now we're kind of forced to go through the code once over and kind of look for any syntactical mistakes we may have made. Pixel array. Yeah, we need to shuffle that around a bit. So I already decided that I was going to do it this way, this more kind of convoluted, broken up way that's going to be harder to do a regex search for, just so that these kind of line up. Also, Chrome Debugger probably won't be able to recognize what this variable is if you break it up like this, I've noticed. But the JavaScript interpreter will do just fine. It'll know what this means. Can move that around a bit. Close that off. Move up here. So you'll notice this wording from the last time I was doing this. Right, I'm just kind of trying to make my comments a little bit more chart-like, just because I feel like I can read it like this better than I can read it as a sentence. That might vary for you. And then we'll just do AKA. And this is just like a little footnote is what this is. This is a footnote right here so that I can identify that this and this mean the same exact thing, in case there's any point where I'm accidentally still using this variable. Since we already have this right here, and I really don't want to deal with it, we're just gonna we can just make a note of what this actually means. So as... Oh, you know what? And it's not... Oh, okay, yeah. Oh, never mind. Those are actually different things. So what I'm going to do to make sure I don't forget that is I'm going to do this. I'm going to actually put these in here with them. So when I double-click, I can see them highlighted, see the association. And then also when I glance at these, it looks like two different... These look like the same variables when I glance, right? And this looks like the same variable as I glance. But now that I see a slash, I'm more likely to do a double take when I glance at this and be like, oh, hold on there. These might be two different variables. Oh, yeah, they are. They're just slightly different, right? Okay, so let's keep going. We might need some type of section divider between these function names. Let's name this closing scope. So function, we don't really care what the parameters are. We just want to close it off nicely. And let's keep on moving up. We might want to make a space here. We're so close to done. The other thing that's kind of catching my eye here is this RGBA. I think we want to just get rid of that. Yeah. It was just kind of like a hackish helper variable, so we can just remove that. Next thing is keep on moving up, I guess. That looks good. Publicly exposed functions. So we have a commit, we have a get, and we have a put, and I believe that's all we have that's public. So now this diagram we worked on kind of needs some reworking, so we gotta like bust it open here, and we're indented twice. So what we're gonna do is we're just gonna take this and comwrap i2x64. Well, that's ugly as sin. What the hell did we do there? Let's paste this again. We must have forgotten. I'm gonna go back a little bit further. I just wanna. Okay. We're gonna use the indentation of 4 just so we get some padding. Okay, then with that, we're just gonna realign and give this some extra space. Okay. And how do we want to do this? So we could kind of like, I don't know. Do we really need space between these thoughts? And how much space do we need between these paragraphs? Like, do we need this double spacing? This seems kind of fluffed up a bit, you know? But, you know, let's just keep on going with this. And that is wrong. Yeah. Okay, and then up here, we'll just seal this off. So now that comment's been kind of, like, reformatted pretty well. Obviously, a lot more labor than most people are willing to put into comments, but I just want everything to look very nice and very organized, very structured. Because then, you know, sometimes when I'm trying to figure something out, things get really dirty. Things get, like, disorganized and they look like shit. And that actually helps me know what areas are, like, currently under construction, if that makes sense. So I'm going to put some breakpoints here. I want to come back here, put some divider lines. Just to make that point, though, if we scroll up through all this code, right, it's like, oh, hey, look at that, look at that. This area must not be completely thought through because I got these, like, semicolons like totally not aligned. And you know what? That's exactly what's going on here. We're kind of hacking away, trying to figure out what the hell was going wrong. We added a lot of code, took stuff away, just added and subtracted things, and it just got out of hand because we were making changes so fast that it just wasn't worth my time to like format it nicely. So that's what I'm talking about formatting it nicely. Kind of helps me see what areas need attention, right? And then we have like this, it's commented out, but it's not commented out like this with color. So I know that, I know some unfinished thoughts are going on here, or this has been kind of hastily put together, and so I know it needs more attention. But the more pristine something looks like, the more well thought out I'm trying to say that I've made it. So what we're going to do here now is, before we finish, we're going to put like some dashed dashed lines between each of these different sections within this class. Oop, my bad. That was not a division between functions. And I'm also going to divide like other sections up at the top. Okay, so that looks pretty good. Right, we got this to mark where the uniform controller is. Yeah, that looks good. I like that. Now I might want to... Well, I do like having that space there. This is just getting particular. Okay, let's see how much time we got. We got 7 minutes. I'm going to take some time to explain to you what the hell this code I just refactored is, and kind of like how it works. So the basic idea is we have this larger rectangle called the rec bounds, and this is mapped to a 512 by 512 region on the master memory somewhere. And once it's mapped there, okay, that's a lie. It's mapped to a region on the master memory, but it doesn't have to be 512 by 512. It can be any power of 2, but starting with 8 by 8. So no, just by my constraints, my design constraints, I'm not going to go any smaller than 8 by 8, because 8 times 8 is 64. That's like 64 different data points I can work with. Anything smaller than that doesn't seem very useful or seems too fine-grained to me. But we're going to take this big region and claim a section of memory as a uniform pool, where we're going to store uniform values in a texture. So when I say uniforms, they're not really uniforms in the sense of a uniform variable, but I'm using them as uniforms. I'm using these pixels on the texture as uniforms. And we'll make a whole interface for doing that, which is kind of like what this object is, the texture as uniform controller. This part up here should be pretty self-explanatory, right? It's just a constructor. And then this is the class body, your little diagram up here that we just kind of worked on about like what it does. So you can, I guess, read that if you want. You can pause and read that. I'm not going to read it to you. Here's our publicly exposed functions: committing the pixels, getting the pixels, and putting the pixels. So uniform commit, uniform get, and uniform put, but they're stored as pixels. That's kind of why I said get, put, and commit the pixels. When we get the pixels, we're actually not going to fetch them off the GPU, but rather just get them off of the CPU side data and just make sure that data is synchronized properly. When we do put, we're going to put it on the CPU side, but we're not going to actually push it up to the GPU side until the commit function is called. And that's because we don't want to do a like GLText sub-image push with just one pixel in it. That would be highly inefficient, so we want to try to be considerate of our GPU bandwidth. Okay, so we got our private variables. We have our borrowed pointer U32 pix. So this is a one of our uniform containers, is what we called them. Uniform container is really the wrong name for this U32 pix object, but that's the name we kind of had when we started making the classes for the integer uniform and the texture uniform. So they're stuck with that naming. I'm just going to keep it that way. But anyways, this is a very obnoxious variable name, and that's very intentional. It's because I want to make it very obvious that this U32 pix instance that is in here it's not your memory. You're referencing someone else's memory. So if we ever destroyed this this whole object in C code, we wouldn't touch whatever it was borrowing, right? Because that pointer belongs to somebody else. So doing like a free on this variable would be a big no-no. We'd end up with some big problems. So I just want to make it obvious who owns what data, if that makes sense. So then we have a rectangle for dirty, so it's the dirty region rectangle, which is this rectangle in here. And this is as we start to set uniforms onto the allocated region, like we're starting to set those pixel values that are used as uniforms. This bounds will cover where all of those uniforms have been set. So that way when we do a GLText sub-image like update, and we're trying to push all of those uniforms, we just have to push the bounds of wherever they have been set, right? So it's not perfect, right? Because, you know, maybe you set a value here, and you set one here, and then you set one here. And so it's only like 3 that are being set, but you're like pushing this gigantic area, right? And that's kind of wasteful, but it's not as wasteful as this, right? So it's not perfect, but it's... I don't want to make my code too complicated, right? So this is already kind of, to me, this is already kind of complicated and fancy, and I don't want to get any more complicated and fancy than this. So I know this is not a perfect solution, and a lot of like how I lay out my data and what the data access patterns look like is going to like change the performance. But we're not going to get any fancier than this. This is good enough. Then we have our use dirty rectangle, and this is because if we have not set any values since the last iteration of the game loop, well, this rectangle will still exist. So we want to flag to not use this rectangle, to invalidate the whole entire rectangle, especially because there's no such thing as invalid values technically in this rectangle, because we want this rectangle to be composed of unsigned integers. Well, I mean, technically, like, you could say, oh, the rectangle is invalid when we just throw it out of bounds. That doesn't make sense. So yeah, we just really need a variable that says to us that this rectangle has no valid state. So, because let's say this rectangle is valid, and then we push up all of the pixels that are inside this rectangle. Okay, now what do we do to the rectangle? Because now we don't need it anymore. Well, it still exists. Oh, do we shrink it? Well, it's an inclusive rectangle. So the problem with that is an inclusive rectangle, the smallest it's going to get is an area that is 1 by 1 pixel. There's no way to make this inclusive rectangle 0 in size because of the convention of how I'm programming this. Right, because I use a, right up here is x0, y0, and then down on this bottom right corner is x1, y1, right? So, right, it's an inclusive selection area. Now, if we're using something that had like a origin, and then a width and a height, right? Then we could set width and height to 0, and we could effectively invalidate the rectangle by just setting that value. But we can't, because I'm going to prefer to always use rectangles that are inclusive selection areas rather than using the whole like origin and width height thing, just because I find the math easier to work with and conceptualize. Okay, so next variable we got here is the rectangle bounds, and this is the outer bounds. So you see rect bounds right here, and this is the boundaries of all the data that you're allowed to use. So trying to set anything out of this region is a no-no. Now, I think I might want to actually check to see if I check it if I'm actually like making sure that that data is being accessed within bounds. So the put and get functions actually use a little helper that calculate, right, and it takes the index. And when we're mapping this, so we get an xy position within the bounds, bounds.tx. Yeah, I don't see, well, I see this, pix width and pix height, right, px. Okay, and that makes sense, because pix width and pix height. Oh, okay, I see what's going on here. And there's no offset because why? That doesn't quite make sense. Okay, well, that's because this is at 0, 0. So I feel like this needs some. I'm gonna stop recording.